if I've gone forward and I've collected data from, let's say, 500 people, now for me to sit through each of the data will obviously be very tedious. So I don't sit with each of the responses, but I sit with the totals that, on a particular thing, how much has somebody scored? And then based on that, I do comparisons and I do this and I do that. So you're looking at collection of data, you're looking at organizing it in a form that allows you to run a particular statistics. Now, those of you who are, let's say in your undergrad, you may have at least started doing basics on manual calculations and statistics. Those who are in postgrad, you already may have your dissertation going on or coming up ahead. So you know that, you're collecting a lot of raw data and you're converting it into data that you're going to use for analysis. So all of that comes under the purview of statistics. Now, particularly when we do it from a psychology perspective, there are certain things which are a little different from how we do it for math, but the overall perspective still remains the same. We are still doing it with a particular agenda in our mind, and that agenda is you want to draw I'm so sorry, just give me one second. Yeah, so that agenda is you're trying to draw some insights, you're trying to draw some conclusions, gain some understanding of the data that you've collected. Now, because when you're asking people, what do you feel about this new movie Fighter that has come up? Or let's say, what do you feel about Hanuman as a movie that has come up? And then you tell someone yes, you ask someone, so you give them three options: yes, no, I haven't seen it yet, unsure, I don't want to give my comments. And then you have like so many different responses coming from different people. And then you sit down to kind of compile them. You sit down to maybe draw different ways of representing the data to then understand, okay, how many people have not seen it yet, how many have said that they've liked it, how many have said that they disliked it. So all that is where we come to the segment of what we call as descriptive statistics and inferential statistics. So statistics in itself, when you start reading about statistics, there are a lot of key concepts that come. We're obviously not going to look into the key concepts as of now, because then it's like a whole sea that we are wanting to discuss. But usually these are words that you would very often come across. You're looking at understanding what is a population, you're looking at understanding what is a sample, what are the different variables that we can work upon, how every variable has its own terms and conditions on which it can function, how every variable will have a particular test for you to give and get scores, or some variables could be just as you ask people to select their gender, male, female, don't want to specify. So a varied range of variables that we could be dealing with when we are even looking at a research work. Then of course data types will be many. You'll have very different types of data that is coming to you. Review of math is more important when you're doing manual calculations and statistics. So if you remember how we did BODMAS rule in school, where we had bracket of division, multiplication, that entire that entire process that we were taught back in school. So that becomes more handy when you're doing manual calculations. You wouldn't need it much when you're sitting down on an SPSS or a Jamovi on an R to kind of run your analysis for the data collected. And then of course we get into the descriptive and inferential statistics, which is all about how or what are the different possibilities, what are the different analyses that we can subject our data to. Now this is where, before I jump on to just one second, just give me one second. Yeah. So now this is where, when we go down to understanding the different descriptive and inferential statistics, it's important for us to understand that, the same thing could be subject, or the same data that we're looking at could be subject to multiple analysis. And this is where a lot of times, as individuals, we tend to go a little haywire. We think that this is a study where if I'm applying one type of analysis, I can't apply any other type of analysis, but that is not the case. The case is that based on or because of the kind of data that you've collected or because of the kind of study that you're wanting to do. In the same study there could be multiple different analyses that we can apply. Of course, each of the analyses will come with its own terms and conditions, and based on their terms of conditions, if it suits the kind of data that we are working on, we then take a decision on how or where are we going to use what. So that's basically what I'll be taking you through, like I said, on a very surface level, but this is where I'll be taking you through in terms of how do you take a decision or how do you take a call in terms of which of the analysis would be the best to use or should be used based upon or depending upon the kind of data that you are planning to collect. Now, when we talk about descriptive and inferential, one thing is very evident from the name, and unfortunately something that we are never taught when we are studying in schools and colleges, but as we grow up, you realize that it was so much simpler if it was just taught like that to us. So when you look at descriptive and inferential, all that it's talking about is descriptive talks about giving a basic description of the data that you've collected. So a basic pie chart, a basic bar graph that we are looking at. So how you have surveys coming in the television, how you have different line graphs, and you have bar graphs coming in the newspaper or in survey in magazines, or even on, like I said, on television. You have a pie chart. 60% people said that they really liked this particular advertisement. 20% said they didn't like it much. 20% say that we don't want to give a comment on the particular advertisement that you're talking about. So you are looking at very basic outline or a very basic description of the data, where you're just able to describe what is the kind of data that you've collected. Now, inferential, of course, goes a step forward, and inferential does not just stop at telling you what is the trend, but it also lands up telling us how this trend can be explored further, how different people or why did different people have different reactions to this particular result that we have achieved. So descriptive basically describes the data, gives us a basic outline or a basic idea. Inferential allows us to draw inferences or allows us to draw further conclusions or further information on the data that has been collected. So when you look at descriptive, because it's talking about a basic outline, or just basically because you have so much data that has come to you, if you put that entire table in front of me, I'm going to get lost in that data. I'm like, why are you showing me data from 200 different people? What should I do with this? So now for you to put across your point to me that the 200 people that I went to, they had this and this to say, that is what descriptive statistics allows us to do or helps us to do. It allows us to compress the entire range of data we may have collected and summarize it in a manner which becomes very easy for a reader to understand, because no one's interested to know how every single person has answered on a particular thing. Nobody really has the time. When you're in a business meeting, nobody wants to know what every individual amongst those 500 said about something, unless it's something where I want to know every individual's response on the item. But if I want an overall understanding of a particular drug that I'm going to launch in the market, or a particular celebrity endorsement that I'm going to launch, I don't want to look at what every person said. If you are coming to me with your presentation, all I need to know is give me a conclusion, give me a summary on this is what has come out, and then I'll see whether it's in our favor or it's not in our favor. Now that is where descriptive statistics come handy. So you're looking at all sorts of tables and diagrams, you're looking at frequency tables, you're looking at graphs, you're looking at measures of central tendency and measures of variability, which commonly come under descriptive statistics. Now tables, diagrams, bar graphs, pie charts, frequency tables, you can see I've put an image on the right hand side. So you are kind of, for all the data that you have, you've either made a pie chart out of it or you've made a bar graph out of it. Now, just by looking at the image that you're showing me or the infographic that you've used, I kind of get an idea that, okay, for whatever data you collected, I can see in one case males have scored higher than females because I can see the bar bigger for males. When I ask people about their favorite car color, I can see white has 24%. So I know that, okay, 24% of your population or of the group of people that you have reached out to, they prefer white as their favorite car color. And then that gets followed by black, followed by silver, and so on and so forth. So this makes it very easy for us to summarize and want to just convey to someone how or what kind of trend have we seen based on our study. For any research that we are doing, for any dissertation that we are doing as part of masters, for a PhD that we are doing, descriptive statistics and inferential always happen simultaneously. Now, what happens is when we are putting down our methodology, when we are writing our chapter on what is the statistical analysis we are going to run, we never write we are going to run descriptive statistics as a point, but it goes as an unsaid thing that when you are running inferential, you are definitely going to run descriptive as well before you even go down to exploring the data further. Have you at least explored the surface level? Have you explored what is the kind of data that you've got? And only then you go down to performing the further so-called complicated statistical analysis that you've proposed for your study. So now when you look at measures of central tendency, this is something that we've been doing back from school. You have the basics in terms of mean, median, and mode. And for any sort of further statistics, whether you're looking at correlation, whether you're looking at t-test, whether you're looking at ANOVA, for all of them, central tendency, or for that matter, the mean or the average, is like the groundwork on which all of these further statistics are going to rely. So that's why I told you that, descriptive, even if it's not mentioned that we are going to calculate the mean, standard deviation, this and that, it's an unsaid thing, it's an understood thing that you are going to calculate them, because when you do manual calculations, you realize every further statistics is going to make use of these basic statistics to build up on a particular set of data that you've collected. So this becomes where we are looking at central tendency in terms of what is the average that a group has scored, or what is the average performance shown by a particular group. And we always need that average to know who is, or who are those people who've scored around the average, and we always want to know who are the outstanding performers, whether it's in terms of scoring really, really low or in terms of scoring very, very high. We always want to look at this complete picture to understand that, okay, what is the typical score around which most of the people have scored, and then who are those, or what are those scores which are those highlighted ones, very, very low or very, very high as compared to the average. So central tendency gives us that first possibility to understand what is the average. Median and mode, to be very honest, does not come too handy when you're looking at when you're looking at using SPSS, or you're looking at using Jamovi. Usually from central tendency, it's mean that gets calculated the most, and from measures of dispersion, it's basically standard deviation that comes most handy, based on which all further statistics are calculated. Now, dispersion, basically, if I have to give you in one line, it basically talks about not the center scores anymore. It talks about those extreme scores, that how extreme are they? Are they so extreme that they are becoming problematic in our calculation, or are they different from the average, but they're not very different? And that's the kind of difference you're looking at. I mean, if you make a very easy class test, you're looking at everyone scoring very, very good. So you don't even want a picture like that. When you make a very difficult test, you're looking at everyone scoring very low. Again, not a very ideal situation. But you make an average difficulty test because you definitely want most of the people to score around each other. But then you always want to look at those exceptions who are either scoring very good on the test, showing that they have studied beyond the given, or people who've scored very, very low, showing that they have not put in enough effort to study for the test. So generally, we are always looking for a spread like this. We are never looking at everyone scoring an average, because that does not reflect very well on the kind of work that we've done. So now that's where measures of dispersion comes into picture, where we are looking at, are your extreme scores still within the range of the average score, or are your extreme scores so extreme that it's nowhere close to the average, and you have one cluster in the average, and then you have some two, three people extremely away from the average score. So that also takes us to something which is known as measure of shape and distribution. So if you've heard of something known as the normal probability curve, is where we are trying to understand that definitely people would have scored so sorry. Definitely people would have scored more or less than the average score, but how much more or how much less? Is it still in our acceptable range, where we can call, where we can say that, okay, most of the people have scored, let's say, around around 50%, 60%, 40%, and some who have scored around 80% or around 30%. But we don't want a situation where most people have scored between 40 to 60%, and there are a lot of people who've scored above 90, and then a lot of people who've scored below 10. That's a kind of very rare situation that we want to look at, because then that means you did not have a very homogeneous group of people who were sitting for your exam. Then you've just randomly picked up people to answer your scale. So most of the people are somewhere around the average, but then you have one group who's like absolutely on two absolute extreme ends, something that kind of disturbs the entire curve that you're wanting to plot. So this is also something that is run before we run the inferential statistics to know because see, when you're collecting data for a research, you don't know what kind of data is going to come to you. You can never know because you're finally reaching out to people. So you don't know what the person is going to fill, how that is going to add up to a particular total. So these things can only be run when the entire data set has come to you. And it's only then that this comes as a surprise. So either you can be very happy that, okay, for whatever data that has come to me, it more or less, falls under an acceptable range. So even though there are some extreme scorers or low scorers, it's still in a manageable domain. But then you could also be taken for a shock that, you have some people who've scored so high or so low that it has disturbed the entire average of that particular group that we are working on. Now, okay, I'll take questions just about in the end. I'll give you about 5-7 minutes to take questions. So you can put it in the chat if you want to for now. So measures of shape and distribution are also run as a part of descriptive or as a preliminary, analysis that we are doing before we jump on to the inferential statistics. Now, inferential is, of course, any study is incomplete without inferential, because if you're just calculating the mean or the standard deviation, you could just be working on a very basic survey. You've not want to go beyond that. So it could just be a very basic survey that you're wanting to collect to just know how many people have said yes, how many people have said no. But inferential is where you're going much deeper. You're going much more into working around the data that you've collected to get to know as much as you can about the group of people that you're wanting to work upon. So these are, of course, this is where complications begin. This is where all complex statistics starts to come in, because as simple as descriptive sound, inferential, of course, they are complicated, but for the sole reason that they are adding so much more value to the effort that you've put in to collect the data from different groups of people. So the most common statistics that are usually used are correlation, regression, t-test. You would have heard of ANOVA, MANOVA, two-way ANOVA, MANCOVA. The list goes on and on and on. So they are all used basically with a different perspective in mind. They are used for either studying differences or studying relationships. I will just take you through that as well. But long story cut short, the one advantage that inferential has over descriptive is it does not, like I said, it just does not tell you how has the data been or what is the average or how many people are around the average. It now goes beyond. It now goes how these particular scores can tell you so much more about the larger audience that you're looking at, because obviously not everyone from the audience can be part of your study or can be part of your survey. So this allows you to make generalizations. This allows you to understand that if a group of 100 people have behaved in a particular way, can I say the other 1,000 people who are a part of this group are also going to behave in a similar pattern or not? We can never say the same pattern, because once again, we are talking about people, and people are very, very unpredictable. But you are just trying to make a possible prediction that if 100 people have said yes or no about a particular thing, or they have agreed or disagreed about a particular thing, can I say with some conviction that the remaining 1,000 who are a part of this group are also going to have some similar ideas or similar perceptions? Now, inferential, of course, then when you get into hypothesis, again, that's a world of its own. We are looking at null hypothesis. We are looking at alternate hypothesis. Every time that we are wanting to do a research, this is like the starting point. Once you've identified your variables, you directly go down to understanding what kind of a hypothesis am I going to propose for my study. Now, again, just like I said, descriptive and inferential always go hand in hand. Null and alternate hypothesis are also like two sides of a coin. They can't exist in the absence of one another. here, because if you're getting heads, you're definitely not getting tails, and if you're getting tails, you're definitely not getting heads. It's the same when we talk about a null hypothesis and an alternate hypothesis. So null always starts with the premise that two things are unrelated to each other, or two groups of people are not different from each other at all, or people coming from two different places of living are not different from each other at all. So this starts with the premise that your groups are equal. They're not different from each other on whatever parameter you're wanting to judge them on. Now, if this is one side of the coin, the other side of the coin is obviously going to say, no, 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 I'm sure there is a relationship, or I want to start with the premise that, people coming from rural area versus urban area are going to be different in terms of their, let's say, mental health. Or I'm going to say that, males and females are going to have different perceptions about a movie that is going to get released. So alternate will speak on the other way. Alternate will not start with a premise that two things are unrelated or they don't have a difference. This will start with a premise that there can be, or there is going to be a difference. And then we are only going to judge it after the data has come to us, whether, we are actually going ahead with, or we are actually after running the analysis, we do know for sure that there is a difference, or are we concluding our study saying that no, there is actually no difference for whatever reason, that all that comes as a part of the study that we are doing, the kind of data that is coming in, and how we are, kind of analyzing that. Now, so when making comparisons, you're looking at either null being true. Now, obviously, if null is true, you are obviously rejecting the alternate. And if null is false, you're obviously accepting the alternate. Like I said, it's two sides of the coin. If you're getting heads, you're not getting tails. If you're getting tails, you're not getting